Since the dawn of human history, we have looked to the heavens in search of answers. The night sky, patterns of stars and mysteries, has always been a source of wonder and inspiration. Ancient civilizations built entire philosophies, myths, and scientific frameworks around the celestial bodies that hovered above them. But as our telescopes have pierced deeper into the cosmos, we've discovered that the reality of the universe is far stranger and more awe-inspiring than anything our ancestors could have imagined. Our journey today will take us to some of the strangest and most wondrous places in the universe. Places that stretch the limits of our imagination and the boundaries of science. Each of these destinations offers a glimpse into the extraordinary, reminding us that the universe is not only a physical realm, but also a place of deep philosophical significance. To understand it is to understand something fundamental about ourselves. The universe is not just a space of order and beauty, it is a place of extremes, where the laws of physics stretch to their limits. It is a realm of paradoxes and enigmas, where creation and destruction are not opposites but partners in the eternal dance of existence. The more we learn, the more we realize how much we don't know. And perhaps this is the most humbling revelation of all. We are tiny, fleeting sparks of consciousness adrift in an ocean of time and space. When we look at our planet from afar, its vibrant blues and greens remind us that life is rare and precious, yet Earth is just one world among countless others. The observable universe alone contains an estimated 100 billion galaxies, each teeming with billions or even trillions of stars. Around these stars orbit uncountable planets, some familiar, others utterly alien. Among them are worlds that challenge our very understanding of nature. Planets that rain molten glass, stars that defy conventional physics, and galaxies shaped in ways we cannot yet explain. But beyond the physicality of it all lies something more profound. The cosmos forces us to confront the big questions. Why does the universe exist? What is our place within it? Are we mere accidents of cosmic chance? Or is there a deeper purpose to our being? These are not questions for science alone. They touch the realms of philosophy, spirituality, and the human heart. To gaze at the universe is to feel both insignificant and deeply connected, a paradox that defines the human experience. Born in 1473 in the town of Toruń, Poland, a man emerged whose idea challenges the very foundation of our understanding, forcing us to confront our place in the universe. Educated across Europe in law, medicine, and astronomy, he observed the heavens with a mind unafraid to question the conventional wisdom of his time. With his heliocentric model, which placed the sun at the center of the universe rather than Earth, he not only revolutionized science, but also invited humanity to reconsider its perceived centrality in existence. In his quest for truth, he revealed that our world is but one of many, orbiting a distant star in a universe vast beyond comprehension. This was the profound legacy of Nicolaus Copernicus. Our universe has been marked by milestones of curiosity and innovation. Early astronomers like Galileo and Copernicus redefined our understanding of our place in the cosmos. The invention of the telescope opened up new worlds, while modern spacecraft and observatories like the Hubble Space Telescope have allowed us to peer into the farthest reaches of space. Every breakthrough has brought with it a new sense of wonder and new mysteries to unravel. With the help of their crucial discoveries, have laid the foundation of our journey. Today, we will visit some of the most weird planets where shards of glass rain sideways in a furious storm, where endless oceans stretch beyond sight. We will explore a galaxy shaped like a perfect ring, defying conventional structures, and a star so dense that it might hold clues to the nature of matter itself. We'll delve into the chilling mystery of the cold spot, a region in space that might suggest the existence of parallel universes. And finally, we'll marvel at the birthplace of stars in the Eagle Nebula's pillars of creation. Each of these cosmic phenomena challenges us to think beyond the confines of Earth. They invite us to contemplate the extraordinary variety of the universe and the deeper meanings hidden within its mysteries. What do these places tell us about the nature of reality? How do they reflect the limitless creativity of the cosmos? And how do they inspire us to continue our quest for knowledge and understanding? For every discovery we make about the universe, we uncover new truths about the human spirit, the drive to explore, to question, and to seek meaning in the vast unknown. So let us begin this odyssey of wonder. The universe awaits, with all its mysteries and marvels ready to be unveiled. You're watching Space 9, unveiling the mysteries of the cosmos, your gateway to the universe. The glass rain planet, known as HD 189733b. Let's begin with a world that's as alien as it is hostile. HD 189733b, an exoplanet located 64 light-years away in the Vulpecula constellation. From a distance, it might appear deceptively familiar. Its deep azure hue, shimmering with a rich, ocean-like colour, bears a striking resemblance to Earth's own blue planet. Yet the reality lurking beneath this beauty is far more sinister. This deep blue is not a sign of tranquil seas, but the result of silicate particles in the atmosphere. These tiny grains scatter blue light, giving the planet a striking appearance. But what seems like a serene, almost picturesque world is in fact anything but peaceful. HD 189733b is a gas giant, slightly larger than Jupiter, and it orbits its star so closely that a single year on the planet lost just 2.2 Earth days. The extreme proximity to its star generates unimaginable heat, raising surface temperatures to over 1,700 degrees Fahrenheit, 930 degrees Celsius, far hotter than any environment we could survive in. In addition to the sweltering temperatures, the atmosphere is anything but calm. Winds whip through the skies at an incredible 5,400 miles per hour, faster than the speed of sound. These hurricane-force winds make it nearly impossible for anything to survive on the planet's surface, creating a chaotic environment where stability is a distant dream. But here's the most bizarre feature of all. It rains glass sideways. Yes, molten glass. Glittering droplets of silicate are hurled across the planet by the fierce winds, slashing through the skies in a relentless storm of destruction. These molten glass particles, which can reach speeds of over 4,000 miles per hour, tear through the atmosphere in waves, cutting through anything in their path. The planet's violent conditions make it a place of utter chaos, where beauty is built on brutality, and nature's creativity manifests in the most extreme forms imaginable. Studying worlds like HD 189733b challenges our deepest assumptions about habitability and the conditions required for life. It reminds us that the universe, in all its vastness, operates with a creativity far beyond what we might expect. The extreme forces that shape this world, from the scorching temperatures to the deadly winds and sideways rain of glass, push the boundaries of what we can even conceive. It raises profound questions. What other alien atmospheres might exist beyond our wildest imaginings? What else might be out there, waiting to challenge us, to stretch the limits of possibility, to show us that life and even beauty can exist in forms that are utterly alien to us? Though it might seem inhospitable by our standards, planets like HD 189733b show us just how boundless the universe's imagination truly is. In a universe of infinite variety, the possibilities for other worlds, no matter how strange, are as limitless as the stars themselves. The question now becomes, how far are we willing to push our understanding of life? And what wonders might we discover in the depths of the unknown? Hoag's object, the perfect ring galaxy. Next, we journey to one of the most visually striking galaxies in the universe, Hoag's object. Located 600 million light-years away in the Serpens constellation, This galaxy is a true cosmic anomaly, in a universe filled with a variety of galactic shapes, spirals, ellipticals, irregulars. Hoag's object stands out for its stunning, almost unnatural symmetry. At first glance, Hoag's object appears as if it could be the creation of a cosmic artist. Unlike the spiraling arms of a typical spiral galaxy or the oval shape of an elliptical galaxy, this galaxy is a near-perfect ring of stars encircling a brilliant central core. Its symmetry is so rare that it has puzzled astronomers since its discovery in 1950 by American astronomer Arthur Hoag, after whom it is named. To this day, its structure remains one of the most mysterious in the entire universe. At the heart of Hoag's object lies a core populated by older red stars. These stars are much cooler and dimmer, shining with a deep amber hue that contrasts sharply with the glowing blue ring of younger stars that surrounds it. The outer ring sparkles with clusters of young hot stars that have only recently formed, their blue light signifying their relative youth and energy. Between the core and the outer ring, there exists a region of seemingly empty space, a vast void that makes the symmetry of the structure even more striking. The central question that has plagued astronomers for decades is, how did this bizarre structure form? Hoag's object seems to defy the typical processes that shape galaxies. There is no clear mechanism for how this ring and its void came to be. One prominent theory suggests that it could be the result of a galactic collision that occurred billions of years ago. In this scenario, a smaller galaxy passed through the center of a larger one, disturbing its structure and creating the ring-like formation we see today. The interaction could have triggered a burst of star formation along the outer edge, resulting in the glowing blue ring. While this galactic collision theory offers an explanation, it remains a subject of intense debate. Another possibility is that the ring is a result of the gravitational forces, the stretching of the galaxy into this unusual form over billions of years. These forces could have acted on the galaxy in such a way that the central core remained relatively undisturbed, while the outer regions were stretched into a perfect ring. No matter the cause, Hoag's object stands as a reminder of the universe's boundless creativity. In a cosmos where chaos and disorder seem to dominate, this galaxy's symmetry appears almost like a cosmic work of art. Its perfect ring structure offers us a glimpse into a reality where the laws of physics and the forces of nature come together to create something that feels more akin to beauty than to mere science. Hoag's object compels us to ask bigger questions about the nature of the universe. What other forms of cosmic symmetry might exist among the stars, waiting to be discovered? What other galaxies, nebulae, and structures defy our expectations and challenge our understanding of what's possible? The universe, with all its grand scale and endless variety, never ceases to surprise us. As we continue our exploration of the cosmos, let us embrace the mystery of Hoag's object, not just as an astronomical anomaly, but as a symbol of the infinite potential of the universe. The more we look, the more we realize that the universe is not simply a place of matter and energy, it is a place where beauty, order, and chaos intertwine in the most unexpected of ways. The cold spot, a cosmic mystery. Now, let's turn our attention to one of the most chilling and perplexing anomalies in the universe, the cold spot. Located in the southern celestial hemisphere, this curious region stands out on the map of the Cosmic Microwave Background, CMB, the faint glow left over from the Big Bang. Spanning about 1.8 billion light-years across, it is significantly colder than its surroundings, a feature so strange that it has intrigued scientists for decades. At first glance, the cold spot's temperature anomaly may seem subtle, but it's undeniably significant. The region is about 100 microkelvins colder than the surrounding space, a small difference that belies the profound questions it raises. This mysterious cold patch suggests that something unusual occurred in the early universe, something beyond the natural fluctuations that we typically observe in the cosmic background radiation. The cold spot has confounded astronomers and physicists alike, prompting them to consider a range of hypotheses. One leading hypothesis proposes that the cold spot is the signature of a supervoid, an immense, empty region of space with far fewer galaxies than we would expect. These supervoids, vast expanses of emptiness, can have profound effects on the surrounding cosmic radiation, distorting the way light travels through them. As a result, the cold spot could be a product of this colossal void, bending and cooling the radiation from the early universe as it passed through. Yet, this explanation, while compelling, doesn't entirely account for the full scope of the cold spot's peculiarities. There's another, more tantalizing theory that pushes the boundaries of our understanding even further. What if the cold spot isn't just an ordinary void, but rather a sign of something much more extraordinary? A glimpse into a deeper, hidden reality. This theory suggests that the cold spot might be evidence of a multiverse, the possibility that our universe is not the only one, but part of a greater cosmic structure made up of many parallel universes. According to this hypothesis, the cold spot could represent the remnants of a collision between our universe and another, a cosmic event where two universes briefly interacted, leaving behind an imprint in the form of this cold patch. If this theory is correct, the cold spot would be far more than just an anomaly in the cosmic background. It would be proof that our universe is not alone. It could mean that the universe we know, with its own set of physical laws, is just one of many, each with its own unique dimensions, forces, and mysteries. Imagine a universe where the laws of physics are entirely different, or where time behaves in ways we cannot even comprehend. The cold spot, then, could be a sign of those realities, a fleeting connection between us and another universe. The cold spot is not just a scientific enigma. It is a place where the science and philosophy meet, challenging our understanding of the universe and the very nature of existence. Does it whisper secrets of parallel universes, of realities beyond our own? Or is it simply a quirk of the cosmos, a bizarre and unexplainable feature of the early universe that remains out of our grasp? Whether it is the relic of a supervoid or the trace of a multiverse collision, the cold spot forces us to question what we think we know about the cosmos. What else could be out there, hidden in the dark corners of space? What other anomalies, like the cold spot, might lie in wait, pushing the boundaries of science, imagination, and philosophy? The universe, after all, is far stranger and far more wondrous than we can even begin to understand. The strange star. In the constellation Corona Australis lies an extraordinary object in the cosmos, the strange star, known as RxJ 1856.5-3754, a neutron star unlike any other. Neutron stars are already among the most extreme objects in the universe, city-sized remnants of massive stars that have gone supernova, with masses greater than the sun packed into a space no larger than a city. But the strange star may be something even more remarkable. Typically, neutron stars are known for their dense, incredibly compact cores. These stars are so compact that a single cubic centimeter of their material can weigh as much as the entire human population. However, what sets the strange star apart is its unique and almost unnerving smoothness. Unlike other neutron stars, which often have irregular surfaces and strong magnetic fields, this particular star seems unusually smooth, as if its outer layers have been stripped away entirely, exposing an incredibly dense, bare surface. The star shines with a soft but unyielding glow, a visual representation of the immense pressure and temperature at its core. This unusual smoothness has puzzled scientists and astrophysicists alike. One of the most tantalizing theories is that the strange star is not just a typical neutron star, but a strange star. The hypothesis suggests that the star might be composed of quark matter, a mysterious and exotic form of matter that has only been theorized to exist in the most extreme conditions. In a strange star, the particles that make up the atomic nucleus, protons and neutrons, break apart into quarks, the fundamental building blocks of matter. If this theory is correct, the strange star could be a glimpse into the most fundamental state of matter, beyond atoms and atomic nuclei. In this state, the familiar protons and neutrons dissolve into a sea of quarks, held together by the strong force, one of the four fundamental forces of nature. This quark matter could exist in a state of matter we cannot replicate on Earth, given the crushing pressures and extreme temperatures required to create it. Imagine a place where matter is no longer composed of the familiar particles we know, where even atomic nuclei dissolve into an unimaginable soup of quarks. Such a star would be a truly alien object, its composition defying our understanding of matter as we know it. If the strange star is indeed a strange star, it offers us a rare window into the most extreme conditions in the universe. It would show us what happens when the forces of nature are pushed to their absolute limits, when the very building blocks of matter are in flux, and where new forms of matter might emerge. Understanding strange stars like the strange star could help answer some of the deepest questions about the nature of matter and the universe itself. If quark matter truly exists, it might offer insights into the behavior of matter at the highest densities and pressures, as well as help explain phenomena such as the formation of black holes and the nature of gravity in extreme environments. Furthermore, the study of such stars could deepen our understanding of the early moments of the universe, where similar conditions might have existed. In the search for knowledge, stars like the strange star serve as both mysteries and beacons, pushing the limits of what we know and beckoning us to explore further into the unknown. As we continue to study these strange objects, we must ask ourselves, what other forms of matter might exist in the farthest reaches of space? What else might lie beyond the atomic, beyond the familiar, in a universe where the rules we know are stretched and tested in ways we can't yet fully comprehend? The strange star may be an enigma, but it is also a profound reminder of how much there is still to learn about the universe. It challenges our perceptions of matter, space, and time, offering us a glimpse into the very fabric of the cosmos. And in that glimpse, we find both awe and wonder at the mysteries still waiting to be unraveled. The water world, located just 40 light-years away in the constellation Ophiuchus, is an exoplanet that has captured the imagination of astronomers and scientists alike. This enigmatic world is a true water world, known as the water world, a planet that might be completely submerged in vast, deep oceans with no land to be seen. Its size is approximately 2.6 times Earth's diameter, placing it firmly within the category of super-Earths, planets that are larger than our own, yet potentially similar in nature. However, what makes the strange star truly fascinating is the possibility that beneath its thick, dense atmosphere, it harbours an ocean that could be hundreds of kilometres deep, perhaps even deeper than any ocean on Earth. Visuals of the exoplanet, the strange star as it orbits its star, covered entirely by shimmering blue waters. The planet's thick, misty atmosphere creates a haze, obscuring any possible surface beneath. Water vapor clouds swirl above the oceans, hinting at the planet's dynamic weather system. The exoplanet's composition remains a mystery, but scientists have been able to gather some key details through observations. The water world is a sub-Neptune-like planet, meaning its atmosphere is thick and primarily composed of hydrogen and helium. It's a world enshrouded in dense clouds of water vapor, which hints at the vast oceans that likely dominate its surface. These clouds create a strange, misty haze around the planet, making it look as if it's trapped in a never-ending fog. The thick atmosphere also contributes to a potent greenhouse effect, raising the surface temperature and possibly allowing liquid water to exist, even at its incredible depths. What makes the strange star even more intriguing is that, Despite its oceanic makeup, it's not likely to be the Earth-like paradise that many might imagine. The planet is far too close to its star, with an orbital period of just 1.6 Earth days, meaning a year on the water world is just over 38 hours. This proximity to its host star results in extreme heat, with temperatures soaring to over 450 degrees Fahrenheit, 230 degrees Celsius. These high temperatures, combined with a thick atmosphere, would likely create the strong winds and extreme weather systems, turning this water world into a kind of superheated ocean, where the water might be in a constant state of vaporization. But despite these hostile conditions, there is still hope that beneath the turbulent skies and heated oceans, the water world could offer some tantalizing clues about the potential for life in such extreme environments. Scientists are particularly interested in the planet's oceanic depths, which could be very different from anything we've experienced here on Earth. The high pressures and extreme temperatures at the depths of the water world's oceans might create a very different chemistry from what we are familiar with, potentially offering insights into the ways that life could exist in environments vastly different from our own. Could the water world harbour life in its watery depths? Or is the planet too harsh, with its constant storms, intense heat, and high pressures? While the conditions on the planet are far from ideal for life as we know it, the sheer fact that liquid water might exist in such a strange environment raises questions about what life could look like in extreme conditions. Could life, if it does exist here, adapt in ways we've never imagined? Or could the extreme conditions of the water world push the limits of life, transforming it into something completely alien? In some ways, the water world's status as a water world invites us to reconsider the very concept of habitability. Just as we search for life on planets with conditions similar to Earth, we must also be open to the idea that life might exist in places far more extreme, in forms we can't yet comprehend. The existence of an oceanic world such as the water world challenges us to expand the definition of what makes a planet capable of supporting life. Even though this water world might not resemble the Earth's oceans in any way we can easily recognize, its discovery compels us to ask, if life can emerge here, what might we find in other seemingly inhospitable corners of the universe? In the vastness of space, the water world serves as both a curiosity and a potential answer to some of the most profound questions we have about the nature of life, the possibility of water-based worlds, and the adaptability of life itself. This water world, so far from Earth, is a reminder that the universe is full of possibilities we have yet to fully comprehend. It's a place where the extremes of nature collide and create a world of wonder, mystery, and possibility. A world that might hold the keys to understanding life beyond our home planet. The Eagle Nebula, the pillars of creation. Finally, we arrive at one of the universe's most iconic and awe-inspiring landmarks, the Eagle Nebula, located approximately 7,000 light-years away in the constellation Serpens. The Eagle Nebula is home to one of the most famous and visually stunning regions of space, the pillars of creation. These immense structures are colossal columns of gas and dust, stretching over 4,000 light-years across. And within them, the stars of tomorrow are being born. The pillars of creation serve as both a cosmic nursery and a breathtaking example of the dynamic processes that shape the universe. The pillars of creation are made up of giant molecular clouds, vast dense regions where stars are born. These clouds contain the raw ingredients for star formation: hydrogen, helium, and other elements. But what makes the pillars truly extraordinary is the way they are illuminated by the energy of nearby stars. The intense ultraviolet light from young hot stars nearby causes the gas and dust in the pillars to glow, creating a stunning, ethereal scene. The pillars themselves are not solid objects. They're made up of dense clouds of gas and dust that are slowly being eroded and sculpted by the radiation from the stars, creating shapes and structures that seem almost sculptural in their beauty. The The process of star formation within the pillars of creation is an incredibly complex and dramatic one. Inside these dark, dusty columns, regions of a high density and low temperature exist. And within these dense pockets, gravitational forces begin to pull matter together, causing it to collapse in on itself. As this material contracts, it heats up, and nuclear fusion begins in the core, creating new stars. The entire region is a stellar nursery, where stars are constantly being born. These new stars are often massive, much hotter and brighter than our sun, and they emit intense radiation that not only lights up the pillars, but also plays a key role in shaping their evolution. What's even more fascinating is that the pillars of creation are not static. They are dynamic, evolving structures. The intense radiation from the newborn stars is gradually causing the surrounding gas to evaporate and dissipate. Over time, the pillars will continue to change, slowly eroding away as their material is blown away by the powerful winds of starlight. In fact, astronomers believe that the pillars, as we see them today, may not even exist in their current form much longer. The process of star formation is a delicate balance between gravity and radiation, and as the stars within the pillars continue to burn brightly, they will eventually destroy the very environment that created them. The iconic image of the pillars of creation that we've come to recognize was first captured by the Hubble Space Telescope in 1995. The vivid, high-resolution images of the pillars were a breakthrough in our understanding of star formation. The bright blues, purples, and reds in these images represent different wavelengths of light, showing us not just the glowing gas, but also revealing the underlying structures hidden within the nebula. These images have become one of the most famous astronomical photographs ever taken, representing the intersection of cosmic beauty and scientific discovery. But the pillars of creation are not just a visual marvel, they are also a source of deep scientific intrigue. They give us a glimpse into the processes that govern the birth of stars and the formation of solar systems. The vast, interstellar clouds of gas and dust that make up the pillars are the same kinds of clouds that existed in the early universe. And by studying them, we gain insight into how stars like our Sun and planets like Earth may have formed billions of years ago. The pillars are also a reminder of the cycle of life in the universe, the birth of stars, the formation of planetary systems, and eventually the death of stars in cataclysmic events that seed the cosmos with the elements necessary for life. For all the beauty of the pillars of creation, there is a deeper message embedded within them. These immense columns of gas and dust, the very furnaces of creation, show us the universe's incredible capacity for life and renewal. As stars are born in these cosmic nurseries, they are also setting the stage for the formation of future worlds, worlds that may one day harbour life. The nebula is a reminder that the universe is not a static place, but a dynamic, ever-changing realm where the forces of nature continually shape and reshape the very building blocks of reality. The Eagle Nebula and its pillars of creation are both a reflection of the cosmos' breathtaking beauty and its boundless creativity. They invite us to reflect on the processes that have shaped our own solar system and to consider the possibilities that lie beyond. What worlds will emerge from the same process of stellar creation? And will any of them harbour life as we know it? As we continue to explore the cosmos, the pillars stand as a testament to the incredible forces that drive the universe forward, creating new stars, new planets, and perhaps one day, new life. The universe, in all its grandeur and mystery, continuously reminds us of how small we are in the grand system of existence. From the breathtaking beauty of the pillars of creation to the strange worlds like HD 189733b, each discovery deepens our understanding, yet simultaneously reveals just how much we have yet to comprehend. The more we learn about the cosmos, the more we realize that our knowledge is a mere fraction of what lies beyond our reach, an endless expanse that stretches beyond the limits of our imagination. As we look up at the stars and peer into the distant galaxies, we are reminded that the universe is not a static entity, but a dynamic, ever-evolving expanse, filled with wonders we have only begun to explore. The mysteries of dark matter, black holes, exoplanets, and cosmic anomalies like the cold spot challenge our current understanding and provoke philosophical questions that have echoed through human history. Are we truly alone in the universe? How did everything come to be? What is our place in this vast, interconnected cosmos? Yet, in this pursuit of knowledge, we also turn inward. The search for answers in the universe often reflects our search for meaning within ourselves. Every new discovery, every new piece of the cosmic puzzle we uncover, invites us to reflect on our own existence. In studying the stars, we explore not just the physical universe, but also the intangible aspects of our human nature, our curiosity, our longing to understand, and our eternal desire to connect with something greater than ourselves. The universe, in all its vastness, becomes both a mirror and a window, a mirror that reflects our deepest questions and yearnings, and a window that offers glimpses into a reality far beyond what we could ever fully grasp. Whether it's the formation of stars in the Eagle Nebula, or the chaotic storms of HD 189733BE, each cosmic phenomenon is a reminder that we are part of something much larger than ourselves. In exploring the infinite unknown, we are not only searching the cosmos for answers, but we are also on a profound journey of self-discovery. As we continue to push the boundaries of exploration and deepen our understanding of the universe, we remain driven by the belief that the answers we seek are out there, waiting for us to find them. But perhaps the greatest discovery of all is not the vastness of the cosmos, but the infinite potential for wonder and meaning within us. Hope you enjoyed this journey. Thanks for watching.